rotations. In a rotation, you're going to be typically provided the angle of the rotation, the center of the rotation, and then the direction. So the directions are going to be clockwise or counterclockwise. And so it's just like an old school clock. Clockwise would be rotating around this way, and counterclockwise is going the other direction. Okay? 90 degrees, 180 degrees, 270 degrees, 360 degrees, so on. Just like skateboarding, if you're going to go up, or even like basketball, you're going to go up and do a 360, you're going to spin all the way around. If you do a 180, you're just going to flip all the way down in that way. And again, we'll see some of these things. So one of the things that a rotation does is that the pre-image and the image are equidistant from the center of rotation. Most of the time, the center of rotation is the origin. So what happens is we will see, let's go down here to rotate around a point. Okay, so I'm going to take this point and I'm going to take this point, meaning the origin, and let's rotate 90 degrees and let's rotate clockwise and see what happens. So I took this point, this is the center, and I went and I rotated down. So let's go ahead and put line segments on there. We can see what really happens here. Okay, and if you look to see what happens, I took E, which is 3, 1, and then E prime, meaning this is the pre-image, and then here's the image, and it went to 1, -3. A rotation of 90 degrees. You can see that this right here is 90-degree angle, which means I went and I rotated it down. And since I went 90 degrees clockwise, I went this direction. If I would have went counterclockwise, I would have went the other direction. Okay, here's what you got to think about. What happened? Well, it turned out that kind of X and Y switched, but then the X became negative. Well, that's one way to kind of think about it, but that's going to be very particular to that exact rotation, a clockwise 90 degrees. What you really want to do is think about the slope. If you're going to rotate 90 degrees, that means that this line and this line are perpendicular. That means that the slopes are opposite reciprocals. So that this one is over 3, up 1. This one's going to be over 1, down 3. This has a slope of 1/3. This has a slope of -3. And that's always going to be true for a 90-degree rotation. Okay, I'm going to move this now. Watch. What if I take this point and I make it here? Oh. This still needs to be 90 degrees. Let's make it up. This has a slope of 4, over 1, up 4. This has a slope of -1/4, over 4, down 1. Again, the coordinates switched, and we had a negative. I can move this wherever I want. If I'm going to rotate it 90 degrees, I'm always going this direction, and the slopes have to be opposite reciprocals. Again, the X value is going to switch. In this particular case, the X value switches to a positive. The X and Y value switch, and then it became a positive. But really what you want to think about is slope. This is left 4, up 2. This is right 2, up 4. Totally backwards. This has a slope of -2 force. This has a slope of +4/2. Totally opposite reciprocals because this is 90 degrees. This distance is the same as long as the point is the same. And again, we'll do other ones. Okay, so we can rotate points. We can rotate a line. Rotating a line is the same thing. We're just going to rotate both things. So let's rotate about a point, and we'll see. So let's take this line and rotate about that point, and we'll go clockwise again, which will put us. Again, that's what rotating clockwise will take it the third quadrant up to that quadrant, and kind of see what happens here. Again, this one went up. Okay, it was 2 kind of away here, it's 2 away from here. This whole quadrant just rotates that direction. This distance it was from the axis remains the same. So again, this slope and that slope are 90 degrees. Take G and thump it up. This is 3 and 2, and this is 2 and 3. This is a positive slope, and this is a negative slope. These slopes are opposite reciprocals of each other, okay? I can look at this one and that one. Those are perpendicular to each other, again, because they have to be. That's what a rotation of 90 degrees are. You're just rotating that thing and keeping this distance the same and swinging it around this way, okay? Probably can even move. Let's go back. Let's see if we just rotate. Oh, we rotated that whole thing, so I could probably just move F wherever I wanted to. Okay? All of these are still that same rotation. Okay? Make sense? Think about how that's going to be true. Take that whole quadrant and just flip it around. -6, 0 to this way. And I could flip it the other direction, or I could flip it again if I wanted to. So let's rotate. Let's take this back to kind of there. And let's, what I wanted to do, I wanted to rotate. Let's do this object around this, and let's do another 90 degrees. And let's go clockwise. So we keep going in that same way, and now it's going to end up over here. So boom, to boom, to boom. Kind of that same thing. If we kept going, we would rotate, and we would end up all the way back here. So this is like horizontal, and then it kind of can be vertical, and then the vertical is going to flip down and become horizontal, and then it would be vertical again. Take this and rotate it about that, 90 degrees, clockwise, and it's going to be down in there. And if I did it again, it'd be right back. You can kind of look what the coordinates kind of do. You know, 6 and 2, 2 and 6, 6 and 2, 2 and 6, and the signs, of course, need to flip depending on what quadrant you're in. 3 and 2, 2 and 3, 3 and 2, 2 and 3. And that hopefully makes sense. This way is clockwise, and if you take the objects and go the other direction, it'd be counterclockwise. Okay, so we can take a point, we could take lines, now we could just take an object. Most of the time, I just do 2 of them. So I'm just gonna rotate F and G in my head. And so it's L-shaped here, and it's gonna be L-shaped here, but the L is gonna be kind of up. Okay, so let's see what that looks like. Rotate this shape about this point. And again, we'll go clockwise again. See how the shape is up? And again, if you want to do it, I would suggest just rotating like 1 or 2 of the points, and the rest of them are obvious because the shape is the shape. Remember, it's a rigid transformation. So the shape is all the same side lengths. I mean, it is the exact same shape. So here's F. See how that's perpendicular right there? We just took F and we just chucked it around. Switch the coordinates, and we had to mess with the signs a little bit. This has a slope of -1/3, this has a slope of 3, and then if you did the same thing for G, take G, this has a slope of, -4/3, and this has a slope of 3/4. Okay, again, opposite reciprocal to each other, and then the whole thing, once you kind of figure out where F is and where G is, then you just draw the shape. You don't really have to do all of them. You probably, maybe even just have to do F. As long as you can just rotate F to here, you know the rest of the shape has to be here because you know that this, instead of being up and down, it's going to be this way. And since it was 3, it has to be 3. This thing was horizontal, flipping it this way, it's going to be vertical. It was only 2 units long, so it'll be 2 units long. Again, if we wanted to take it and do the other direction, so let's take this and rotate this guy about this point, but now let's go 90 degrees counterclockwise. It's going to go yomp, down. Everything's going to be the same. These are almost going to be mirror images of each other because one's this going clockwise and one's going counterclockwise. This is -4, -3, and this is 4, 3. And you can show the same thing. You still have from F to F prime is still 90 degrees. This is 3 and 1, and this is 1 and 3. This is a -1/3 slope. This is a +3 slope. Those are opposite reciprocals of each other, which means these lines are perpendicular, which means you rotated F 90 degrees. Okay? Okay, and we can do a crazier shape like this, but we still know that this length is 3, this length is 2, and then they're connected. So you still know what it might look like. So we could take this, and you probably don't have to rotate all of them, but let's take this, that point, 90 degrees, and we'll go counterclockwise this time, and it's going to go over there. Just think about F. Just rotate F and maybe rotate G. And once you rotate F and G, then the rest of the shape you can just draw. So it goes from here, a slope of 2, to a slope of -1/2. Oh, sorry, too far. And then you can rotate G, you're way up. And then the other one is then you're way over. Again, hopefully that makes sense that it's way close to this axis. You're going to rotate that whole grid and end up way down here. 1,5 to -5,1. This is a slope of 5. This is a slope of -1/5. And once you know where those are, you can go and you can just draw the rest. You can always confirm that you rotated the correct amount. Okay? Okay, so we can rotate a point. But if you can rotate a point, then you can rotate a line. If you can rotate a line, you can rotate a shape. Because once you can rotate one, like you just rotate FG, then you know the rest of the shape, what it looks like. Again, I would rotate just FG down to here, and then you can draw the rest of the shape. Because it's a rigid transformation, you know that it's the exact same shape. Every one of these things are the exact same distance. So if this is 2 by 1, this has to be 2 by 1. This is 5 by 1, this has to be 5 by 1. They have to be the same coordinates. The negative signs just make sense of where they have to go in the problem. Of course, going from here to this quadrant, the x value has to be negative. So again, the negative signs are the easy parts. Okay, how about this one? This is a circle, and let's do different rotations of, let's say, 45 degrees. So I have to listen to this one. This will be hard for me. Just look at the pointer, okay? Let's say I was on M, and I rotated 135 degrees. Well, 135 degrees, well, there's 45, there's 90, there. So if I take M and I rotate about the center, that would be 135 degrees counterclockwise. Okay, let's take J and rotate, no, let's take I and rotate 90 degrees clockwise. 90 degrees clockwise, bump to H. What if I was on H and I went 270 degrees counterclockwise? 270 degrees would be to M. So you've got to be able to look at all the multiples of 90. 90 is just a quarter rotation, right? So 90, 90, 90, 90, right? 360 would be all the way around. 720 would be all the way around twice. 540 would be all the way around and then another half. And then whether you go clockwise or counterclockwise just tells you the direction you're rotating. So you can do things like that. We probably can make a segment. I wonder if we can rotate that point. Probably can rotate A and get AF. Actually, we could measure, well, let's do that. How about, we could probably measure that angle. How about that? So go down here and say measure this angle. Let's pick this angle there, and voila. Can't really see it, but that angle right there is of course 45 degrees, right? And then if we measured, let's do another one. Where was that at? Measure angle. Let's go from here to here, and you get, oh, it did that small one again. That was stupid. I really wanted it to give 135 for this big one, but it doesn't want to do the little one. Maybe if I measure with the points. So measure I, A, F. There we go. Now it actually gave us that angle, which is 135. And again, it's the same thing for circles. Going from I to F is 135 degree rotation, and F to I is 135 degree rotation. Okay? We can do 180 degrees, of course. That should be pretty easy. We can just go measure angle I, A, M, and get 180 degrees, and you can see that they have to add up to 360, of course, right? So hopefully you have an idea of 45, 90, 135, 180, 225, 270, 315, 360. All of those are multiples of 45 degrees, and we should understand on a circle kind of how those angles work. Okay, the last one is, this is the hard one, is what if I wanted to rotate about a random point? And my thing is, it's just as easy as rotating about the origin, except this is your center. So you're still going to take this line segment. So let's say I'm going to rotate F 90 degrees clockwise. So I'm going to go this direction 90 degrees. Well, what's this slope? See how this is over 5, up 1. So I just need to go down 5, over 1. I still do the exact same thing, and I'll show you that that's what happens. I'm still going to rotate F about G 90 degrees clockwise, and I still get that same thing. Look at the two line segments. Oops, line segments. The coordinates aren't as easy because they just don't flip-flop when you don't do this, but these slopes are still the same, and the distance between F and G and F prime and G is the same. This is 5 and 1, and this is 5 and 1, except this is right 5, up 1, and this is down 5, over 1. These slopes are still perpendicular because that's what it means to rotate 90 degrees. So actually, we can take any point or object and rotate it about any center we want. The center doesn't have to be the origin. I can take that center and I can move it wherever I want. And you can see it's always the same length, and it's always perpendicular. It doesn't matter. I can do this as many different ways as I want. I can move this center wherever I want, and it's always going to be 90 degrees. The two lines are always going to be the same. And again, if you look at it, something like this, this is a slope of 1/2, and this is a slope of -2. You just don't look at it from the center. You have to go from G to 1 to 1. And it's really the only difference. Over here, we're always going from the origin, and so you could just look at the coordinate and see I was over 2, up 4. On this one, you can't look at the coordinate 2 and 4. You got to start at G and go over 2, up 1, and then go down 2, over 1. Okay? Hopefully this helps you get started on rotations. Rotations are usually harder than reflections and translations, but if you can go from the basics and rotate a point, then you can rotate a line, then you can rotate a shape, you can rotate a harder shape, you can look at rotations of like different degrees, certainly all ones are 45, and then the hardest one, maybe like a bonus for regular geometry, would be to take a point and some random point in space and rotate it. But again, I'm claiming it's actually the same thing. You just have to count from the center of rotation to the point and then do the opposite reciprocal to get over there. Okay? Hopefully this helps you with rotations.